Um, okay, so hey guys, today is the third video of our CSES problem set series, and we're gonna work for 1 hour and let's see how many questions we can complete. We have done up to the gray code, and next question is Tower of Hanoi, so let's just go for it. So this is the question: that the Tower of Hanoi game consists of 3 stacks, left, middle, right. Like obviously, if you haven't heard of this question, you are definitely living in the rock. So because that's a very famous question and very famous puzzle to do, and let me just explain this what this question means is that, so there is a particular setup and we have some conditions with it. So the setup is that there are basically 3 poles: first pole, second pole, and third pole. Okay, 3 poles are there, and let's name them 1, 2 and 3. Okay, in the first pole there are some discs, so we can say plates. So it's like one plate, over it another plate, and like this, so on. Okay, so like that, and a smaller plate. So the we have to do what is that we have to transfer all these plates from this tower to this tower, 1 to 3rd, and this is basically a helper tower. Okay, this is a helper tower. We can take help of it, that while transferring all these plates from this one first to 3rd, we can just take help of the second tower. Okay, now the conditions are, first condition is that we can only take, while we are transferring the plates, we can only take one plate at a time. Okay, we can only displace one plate at a time. Second condition is that there cannot be a bigger disk or bigger plate placed over a smaller plate. Okay, we cannot put it like that, that this is a one disk and we are putting it on a smaller disk. We cannot do that. It's always be like that, there is the bigger disk in the bottom, and over the top there are smaller and smaller and smaller disks. Okay, so we have to do this. Now we have to calculate 2 things. First is the count, how many displacements of plates it will take to transfer these plates from here to here. Second is, along with that, we also need to record the moves of ours. Okay, so if we are taking one plate, the smaller one, from first to second, we will just do what, we will record this moves as this 1 to 2, and then we are transferring, let's say, some disk from 2 to 3, then it will be 2 to 3. Okay, like this. So we have to calculate these 2 things, the moves and the count of the moves. Okay, so let's just take, if we have only one disk, obviously in that case we don't need any helper. We will just transfer this to here and we have done this. Okay, so we can write from to, and we can take help of this wire. Okay, so when n is 1, answer is 1, that it will take only one move, that is 1 to 3. Okay, now if n is 2, let's see how we can do this. So we have this, this and this. We have 2 disks here, so it's pretty simple that we have to put first disk here. So next step will be one disk is still here, the smaller disk comes here and this is still empty. Then the next move will be, we will put this disk here, so this will now be empty. This is the smaller disk and this has the bigger disk. Now we will put it here and we will just have the solution, right? So how many moves did it take? First move from here to here, second move from first to third move from here to here, so it will take, answer will be 3. Now currently we are only talking about the count. Okay, अरे यार मक्खी परेशान कर रही है. ठीक है. Now let's take a case for n is equal to 3. Okay, this will generalize something maybe. So if n is 3, it's like 1 disk, 2 disk and 3 disk. Second is empty, third is also empty. So now what we will do is, we will move this to here. What will be the next is that 2 disks are here, the smaller one is here and this is empty. Now we'll move it here or we will move it to the last one. Yeah, okay, we did it wrong. Okay, we will move it first to the last one. Okay, it will be this. Now we will move this second disk to here, so it will be like a bigger disk is here, medium disk is here and the smaller disk is here. Okay, now we will move this disk to here, so it will do what? The bigger disk is here, 2 smaller disks are here and this is now empty. So we can put this one disk from here to here. It will set up the base for us, right? There's no bigger disk than this and we want all disk here, so the bottom should be the biggest one. So this will be the case we will be handling, right? So 2 disks are here and we set up the base here, that yeah, we got this. Now we just need to do simple thing, that we have 2 disks and we have to move them there. So that will be just the case similar to what we have, n is equal to 2, right? Isn't it? Yeah, it is. So we will just move the smaller one to here, so it will be like this medium one and this bigger one. Now we will move this here, it will result in smaller one, this will be empty and this will have one bigger and one medium. And now we will move this here and we have the solution, this empty, this empty, and this will have 1, 2 and 3 disks, right? This is our solution. So how many steps did we took? Sorry guys. Okay, so first step 1, 2, 3, 4, 5, 6, 7. So in 7 steps we have our answer. So the answer is 7. So can we like see any pattern here? First pattern is that whenever we are doing it for any bigger number, like while doing it for n is equal to 3, somehow we are gonna get the situation for n is equal to 2, right? That base is here, we will consider this as empty and we have to make these 2 plates to this via, we can take help from this. So this is similar to the n is equal to 2 case. So recursion can be applied here, right? Recursion, why do we say that? Because recursion is basically what? It's basically building up a solution with small set of solutions. Okay, dividing and conquering. So we will do the thing for smaller cases and generalize it for bigger cases. It will ultimately reach the solution through recursion. We don't have to worry about that. So that thing is done. We can do thing like while doing the recursion we can count the moves, or we have a generalized solution here also, that in case of n is equal to 1, solution is 1. When n is 2, solution is 3. When n is 3, solution is 7. So we can take a pattern here, that is 2 raised to power n minus 1, right? Here 2 raised to power 2 minus 1, 2 raised to power 3 minus 1. So this is the solution. If we have n, it will take 2 raised to power 3 minus 1 moves. So just okay, let's see an interesting case here. Just imagine that we have 64 plates and we have to transfer them. What do you think, how much time will it take? So it might be like okay, we can do it in any finite time, right? Let's just say that moving one plate from anywhere to anywhere take 1 second. Okay, so one move is taking 1 second. So how many moves are there when n is 64? So when n is 64, we have this much time. We require this much time to complete this process. And what is this? What does this suggest us? That 2 raised to power 30 is about 1 billion. Okay, so it's 2 raised to power 4 into 1 billion into 1 billion seconds. So that will like approximately reach out to 585 billion years. This much time it will take to move 64 plates if we take one plate at once. Okay, so you can think that how complex this process is. It doesn't look like that complex, but it is. So we have this. So now let's try to generalize this thing, that you can notice one thing, that in these 3 poles or towers, let's say we have these discs here. Okay, what we can do is that if we take these n minus 1 plates and put it here somehow, okay, we put them here somehow. Let's say these are n minus 1 plates, we put here. Okay, okay, we somehow put n minus 1 here. Okay, then we just need to do what? We just need to transfer one plate here, and then these n minus 1 to here. In the similar way we did this from here to here, we have to do this from here to here with the help of this. Like earlier we take this pole's help, later we can take the help of this pole, right? So do we do this say something about the recursion? Yeah, it does. That if we take this tower name is from, this is via, and this is to. Okay, from this to this via this. Okay, so what we can write is that initially we call our solution, we call our function for n coins, sorry, n these plates, and we have 3 variables, that is from, via, and to, right? In this function, what we will do is we will firstly try to do what? We will call the recursive function for n minus 1 coin, n minus 1 plates. We will transfer them from from to via, right, from to, so from to like this, right? I guess you got it. So why is this? You understood, right? We took this from via to. So this second integer, second variable in the second argument signifies from where we need to go, and this signifies from where we need to reach. Okay, so we're from to via, we have to send what? n-1 coins. Now one n-1 plates. Now one plate will be remaining, right? So we can have the base condition also for our recursion, that if n is 1, if we have only one plate remaining, we can just simply print what? We can simply print that we have to go from to 2, right? From say 2, we will print this. Now once we have gone from to via with our n-1 plates, and we have gone to this also, now what we need to do is we just need to call the function again, and we need to put this n-1 from via to 2 with the help of from, right? I think you get it, that we have to go from this second argument to the last argument. So we have to go from v to t, we have to go from v to t with n-1 coins, and through f we can take help from f, this ball, and in between them we will just print every occurrence which we will just print every move, and our every move is obviously from to. Our every move is this. We are always going from the source to destination. It's just that our source and destination are changing in these function calls. Okay, so this should give us the right solution. Okay, so yeah, let's try to code this now. Just a second. Yeah, okay. Let me take my recording page. Okay, it's working fine. Like yesterday it worked up. So it's tower of Hanoi.cpp. So we have a snippet here. Okay, we will have will be given with what? The number of plates, right? So we will just be given with the number of plates, that will be int n and cn n, right? Now we'll be doing what? While after getting this n, firstly we were to print what? We have to print the answer, right? We have to print the answer, then the moves. So our answer is simple, that we will just see out. We will just see out the solution, our solution, right? That is 2 raised to power n, or n times left shift the operator for 1 and minus 1. It's basically suggests 2 raised to power n itself. I just don't want to call the power function, so that's why I did this through bit manipulation. That's basically what it means, is that 2 raised to power n. Okay, 2 raised to power minus n and 2 raised to power n minus 1, and then we will call the function. See, we will call the function with, we have n coins, we are going from 1 via 2 to 3, right? So from 2 and via 1 2 3. Okay, now we will write a function here, that is void solve, and this is basically int n, int from, int via, and int 2. So in this function, okay, and second thing is we will the base condition that if n is 1, we are going from where to where. How do we print? Okay, with a space between them, we are going from to handle, and we will just return. Okay, this thing. Now after being here, we will just solve this again for n minus 1 coins, and going from, now we are going from via with the help of f to 2, right? And in between that, in between those, we will print all the possible moves, that is from to obviously. Okay, we'll just do this from to 2. No, while we are doing this, we are going from from to via, so we will do, okay, from to 2. Yeah, I think it should do the thing. If not anything, it should do. Let's see if we have this got it right. Okay, we will take the input as 2. Okay, got it. Let's see if it runs. Yeah, it ran. And 1 to 2, 1 to 3, 2 to 3 with 3 as input. Let's see if it gives us the right solution. Yeah, 7 moves. So let's open our this, right, when n is 3. Okay, so first is first to third, then first to second, then third to second, then first to third, then second to first, then second to third, and then first to third. Yeah, it's correct. So we can see it, right, that why we did this, because we are always printing from to 2. We are always going from the source to destination. It's just that our sources and destinations are changing through these function calls, as we discussed earlier. So yeah, this is the thing, and let's try to submit this question now. As you can see, this is a pretty good puzzle question. Okay, but yeah, you can like, this approach is really easy to understand. There might be some more approaches to this through some other explanation, but I just find this explanation easy and easy to remember, easy to understand, and it's just that we don't forget things like this, we don't forget explanations like this. So when I firstly learned about this question, I was lucky enough to get this explanation through a very good YouTube channel. That was about 2 years ago when I was in college, and up to today I remember this approach, that how did we do this question, just because I understood the approach, understood the concept we are using here for recursion. And so we just have to do this for each question. We just have to make the like, you understand that approach, which will be hard to forget even after a long time. Okay, so yeah, this is the question. It took us, okay, our recording restarted, I don't know why, but let's just see. Let me see it on another screen. We have, Okay, I don't know why this thing is happening, but it's really okay. Wait. Let me try to run this test case. Is it happening because of this? If I run this test case, let's say, obviously, how will it affect this? But somehow it is happening, and it's making me really worried about the video we are having, because there are like 6 recordings now. What the fuck, man? It broke down into pieces. Okay, in 1 minute it broke down 4 times. So why this is happening, I don't understand, but somehow it is. 210 to 11, and this is now happening today at 2:15. Okay, these are just 10 seconds. Okay, and second thing is, we will the base condition, and where did the first video ends. Just give me some time, guys. Like, I'm going through these recordings. Yeah, fine. And then this 1 second recording. Seriously, man. And then this again 22 seconds. We are up to here. Then this 7 seconds up to here, and then this current recording, which is still going on, right? Okay, I mean, that's fine, because we can do nothing about this. It must be of 7 minutes now. Yeah, no worries, I will merge it anyways. That's the only thing we can do. How to God damn it. Yeah, okay, that's fine. That is just fine. Okay, so we'll move to our next question, and that will be the creating strings. Okay, so with this question, what we have is that, given a string, your task is to generate all possible different string that can be created using its characters. Like if we have this string, we have to tell us, you have to give the possible number of strings which can be created with these characters, and we have to give those strings, output those strings. So basically it's easy if we know basic maths, if we have done the factorial thing, that total number of combination possible with the length of 5 characters is 5 factorial, and we will divide it by the number of repeating characters. Like a is repeating 3 times, so we'll just divide it by 3 factorial. And why are we doing this is because they are identical character. We can switch in our 5 factorial cases. There will be some cases where we are considering all these 3 A's as different, but they are the same, right? So there will be same string in those 120 strings. Okay, so we will have to eliminate that. For this we will divide it by 3 factorial, because a is coming 3 times. Even if b comes 2 times, then it will be divided by 5 factorial over 3 factorial 2 factorial. So that's how it's done. So we don't need to like basically discuss any approach here. So we will just do this. What's the name of this question is creating strings. We can do this right away. Creating strings, so it's CPP, and will be given with be given with a string, right? Will be given with a string. String is, we will take an input of that string. Now after taking the input, we will take a map for character and int mp, and we will count the character, right? This is good. For loop for I to s dot size, and we will just do what? Si plus plus. Okay, so we will do this, and now we have to calculate the factorials. Firstly, we will calculate the factorials for those numbers which are repeating. Okay, let it be value 1. Okay, so now we will go to so we will go to auto it of mp, then 1 greater than, we will do what? Wait a second, and we will just calculate it as this, right? What happened? Isn't it right? What's this error? Okay, we have to multiply first and then equal. Okay, fine. So yeah, this is the, we have calculated the factorial for the repeating characters. Now we have to calculate the n factorial, where n is the size. Okay, so we will just enter val 1. We will take 1 as initial, so 4 int I2, that will be equal to size, right? We will do what is val 1 into equals to I. So now we have this 5 factorial thing, means the upper thing, numerator is this, denominator is val. Okay, so our answer is this, cout val 1 over val and L. You have to do it. How many times the loop will run? This is the, what is the answer? That much time. Okay, so it will be val 1 divided by val minus 1 I plus plus will be run. We will just check that if a string exists, that is all of s exist. I don't actually know for how long the recording was stopped. Let me just check this. Why this is happening, man? This is just making me crazy. Okay, what happened? I don't know. Anyways, what the hell was that? We'll just do this, and let me just check. 227. Okay, there are a lot of, man, there are a lot of breaks. 22, 23, 24, 26. 11 to 22 it ran fine. Then after 22 it break. $150, this is 20 minutes. 210, 10 minutes. Okay, when we have 2 after 222 and 211, this is 10 minutes 40 seconds. Okay, we are here then. 36, 38. then we have 30, 23, 3, okay, 59, 9 seconds. 9 seconds means 24, 9, okay, 25 seconds. So there is a break over about 1 minute, and then here we have 16 seconds. At 30 it started again, and 52 again there is a break of about 20 seconds, and after that it is breakdown again, and now it's running at 227 currently, and yeah, for 2 minutes. Okay, fine, no problem. I have to merge it anyway, so it's just not going well. So yeah, we will go to the next permutation of this string, and we will just output that string. Okay, output as this will do the thing, because while checking it, it will be on the next permutation of s. Okay, it will do the thing. So I guess yeah, that's it. Okay, so we have here is a b c. Copy it, and we will just paste it here, and we will try to run this. Yeah, it ran fine. Our output is 6 only, and it should be 20. Okay, because our input is 5. C in S, I to S dot size si plus plus, val is 1. No, not this thing. Why do we write this? I don't know. Okay, now we will run this again. Yeah, it's good now. So we'll just submit it. Submit. Choose file. Creating string. Open. And we will submit it. Okay, it's giving wrong answer on some of the cases where we have n. Okay, what is n here? This is just a warning, I must say. These are warning, no need to worry about this. But okay, we changed our code, right? Then why is it giving for a b c? Okay, it's correct, but it's wrong answer. 6 okay, so according to this, the cases are okay, but they are not the same in same what I say, same order. The order should also be same. Are you serious? A B B T Y U. I am giving it in lexicographical order, and they are not taking it. What does this shit mean? We have this question right, and why are you doing this? I don't understand that. And how can we do that now? Because how can even we match their output? What we can do in this case, okay, I think why our video is breaking down is maybe our CPU utilization goes about 10. I think so, because you see it was 9 up like just a second ago. So maybe that could be the reason. Okay, so how to do this is 0 upper dot minus 1. We have the answers right. Okay, we have the answers right, exactly right. It's just that the order of the strings is giving us the problem. Okay, so what we can do with them is expectation I plus plus sort all. We are sorting it and then we are doing the thing. So how can we match there? If this okay, this is doing good. It's just while outputting the strings we are having the problem, right? I don't understand really. How can we do this thing? If we check it, see, for ABC, this is the case they are giving. Right, okay, let me just let me just quit these tabs because it's giving me trauma that the video will be stopped again. Okay, so it's giving these cases, and if we write this input as ABC fine, and we open this question which is creating string, right? Creating string, and we run it now. We have the output as this, and what we are having here is ACB BAC, and I'm wait ACB BAC, we are giving this, and what do they want is that, so this is the correct output. I mean, we are giving them this. Ring a bell? No, I don't think so. Okay, so I don't understand, man. What the fuck is wrong with it? We are absolutely right in doing so, right? I don't see anything wrong here. This case should be handled somehow, right? Wait, god damn it, we just outputting 5 strings, man. Okay, so the thing here is that when we are giving the output, it is giving the next permutation right here. Okay, it is giving permutation right here only, and then it's outputting it, so it will output only 5 times, because after that check will be false. Okay, so we have to output the initial string right here. I guess this should do the thing. Okay, this is, yeah. Okay, let's say, okay, now this should do the work. We'll just submit it once again. Choose the file, creating string, open, and we'll submit it. Like these kind of small problems that give such a headache sometimes. Okay, this is done now. Next question is the apple division. Let's go for it. Yeah. Okay, so next question is that there are n apples with known weights. There are a lot of questions of this type when we have coin piles, right? So here we have an apples with known weights. Your task is to divide the apple into two groups so that the difference between the weights of the group is minimal. Okay, so we have to divide these group of apples into two sets with the difference between the overall weights of those two sets as minimum. So one thing we can notice here is that we're given the constant that n can be at max 20, and we can utilize this thing that if n is given at max 20, then how could it help us is that we can take all possible cases. Maybe see, for every apple there are two choices. Let's say we have these two sets, one set and one set. Okay, these two sets, and every apple will have two choices, either go here or either go here. So every apple have two choices, and if there are n apples, the total number of possible combinations will be 2 raised to power n. So maximum there will be 2 raised to power 20 cases. Okay, and that's doable for a computer. If you like think about this, this is doable. Like, this is our maximum worst case. Okay, and this is doable for any computer. So we can just iterate through each of the possible combinations and try to make those two sets, and each time we are making a set, we will just compare our answer. Like, we will take the initial answer as int max, and every time we get an answer less than that, we will update the answer, right? So this is how we can do it. But how will we like assign these apples to different groups? Let's say the initial weight of apple is, all apples are, total sum is of weights is sum. Okay, now we'll run a for loop from 0 to 2 raised to power n this much times, right? We will run this for loop, and what we will do is our video running fine? Let me just say it. Let me just say, yeah, it's going good for now. So okay, so we'll run this for loop for all possible combinations, and we will try to make one set, and the weight of second set will be obviously total minus the weight of first set, because we don't need to output the combinations here, we just need to output the minimum difference possible. Okay, so what we can do is, if we have this, so we will take a variable current sum, that is the sum for that one set which we are taking, which we are trying to create. Okay, and for this one set we will try to do something like we will iterate through 0 to n. Okay, we will iterate through all apples, and all combinations means that maybe sometimes all the apples are in this set is completely empty, or it has only one apple, it has a lot of apples. So every possible case we will check through. Okay, so how we can do it is that we will run a loop, and we will use the we can use the right, we have to check every cases, and for this one approach is here to do this question. Wait, I don't know what just happened, my CPU utilization just went to minus 17,000%. What the hell was that? I don't know, man, that was crazy. Anyways, Okay, so it will be like for every possible case we have a approach here, that if that this loop will be j and this is I. Okay, so what we can do is we can do something like, if I right shift j is odd, if this is odd, then we will assign the current apple, this jth apple, to current sum, means to this set. So current sum plus equal to this array j, right? This is basically an approach which we use mostly, which I have learned for this question, and it's not like that this is the only approach. Maybe there are other approaches also, but this is quite a bit a good approach and an efficient approach, and we can like understand this by doing like, when I is 0, j is also 0. So for the whole loop, if we try to write shift 0 with any other number, it will return in only 0, right? And it is even not odd, so all the apple will go to the second set, first set will contain nothing. When I is 1, so doing this first time it will give us 1, then when we try to write shift for all the other apples, it will give 0, so only this is odd, so this will be in the first set and rest of the apples will be in the second set. So in this way it will iterate through all the possible cases. Okay, this is the way to iterate through all the possible cases here, and let's just code it for the question of apple division. Okay, we are given with number first, int n, size of this array, right, and int a n. This is the vector we will be creating. Why this happens is we press the escape character. Oh, when we press the escape character, our recording stops. Fuck that, man. Let's just change it then. What is stop recording? No. Delete this thing also. Delicious shit. Yeah, okay, now that's why it was happening. Whenever we try to click the escape, it was recording, it was stopping the recording. Okay, fine. So we'll form an array, and firstly we'll just input it, and sum is 0 and sum is 0. So for I to n, we will just do what is, we'll take the input and we'll create the sum. Okay, so now if we put the escape, our recording won't stop. Perfect. So now what we will do is that okay, we have the sum. Now we will iterate through all the possible cases, right? So our initial answer will be int max, and we will iterate through int I0 to I less than 2 raised to power n, which basically means 1 left shift n, and I plus plus. And while we are here, what we will do is we will create this variable, and we will run a for loop for int j 0 to n j plus plus j plus plus. And now here we need to decide which apple we need to include in the set and which we don't want to include. Okay, so we will just do this. If I right shift j is odd, and how will I check if it's odd? It's just this way to check if the number is odd. And if this is the case, we will just csum plus equal to aj. What happened here? Okay, it should not be a comma, it should be a semicolon. Okay, and every time we come out of this loop, we will just check answer is equal to min of answer. Or the difference between the two sets now, and then difference will be, first is csum and sum minus csum, right? What the shit. Anyways, so we'll do this and we will have the answer, right? And then we will try to print our answer. Cout answer, and now let's try it for our test case. This copy, we'll go to this, control A and V, and run this. There are error messages. Why there are error messages? Why it's not like considering this? I don't know, like I don't want to mess this up now, so just try to run it on some online compiler, online C++ compiler. Okay, we'll just do this and control C, and where's the input field? Where's the input field, man? We have to give the input. Fuck this, man. Where's the input? I don't have any. So online C++ compiler, GDB, is it running? It's down a lot of times. Okay, so these are our 3741, and our code is control A C, and we'll run it. Absolute of long and long int. Why is this? Oh fuck, man, this is not the thing we were saying. Absolute difference, right? So it should be a minus sign. Okay, shit. Okay, the difference is 1. Is the answer 1? Yeah, it's 1 for this, so we'll try to submit it. I don't know what I'm doing right now. I'm doing a lot of unnecessary mistakes. So okay, let's try submit this, and yeah, it's accepted. So yeah, that's fine. The time 2:54, and I guess which I 1:45, so it's already 1 hour. So that'll be it for today. We did how many questions? Is we come here, Apple division, creating strings, Tower of Hanoi. Did we do only 3 questions, man? I think so. Yeah, I think so. But yeah, that's fine. These 3 were top-notch questions, as you can see. These 3 were really good questions, man. Only 32,000 people have done this. And these 3 will be a lot more good questions. I'm not sure I'll be able to do them or not, but I will just give them a try. I will try to do them. I'm not sure will I be able to do them or not. Then we'll go to sorting and searching, and we'll try to do as much as we can. Okay, so yeah, that's it for today, I guess. So bye bye guys, that's it for today. Thank you.